Testing, 1, 2, 3. 3, 2, 1. Alright, looks like we got sound. Yep. Okay, I haven't updated in a while. I've been playing around with a few ideas, and I finally not zeroed in, but like resolved, okay, this is how my system's going to work, and I got something pretty solid that will allow for a lot of things that most layout systems would have a really hard time with. So, but this is totally different from what would normally be done. So I'll try to, first I'll show you what I got. So this is, from my experimenting, this is what I have so far, and it's not the best, but it's definitely like it's the concept though. We're getting the concept. So we can align things, and they're in 3D. We have 3D backgrounds, see, and it's done procedurally. So let's see. The main concept here is that, see, there's a this is a tree, right? So this is my prefab. This is just the scene right here, and then this is my prefab. I just started with a column just to see what I could do, and just playing around with the code that I already have. And if we go orthogonal here, you can really see that there we got borders and stuff, and everything's in a tree. So that's the column, and then you have a tree. So you have, that's one thing, one branch in. So this is a branch, and then that's another branch, and that's another branch. And these are all duplicate items just for experimentation. Normally these would be in prefabs, so they wouldn't know exactly which column they're being added to. In this case, I was just able to say, okay, here's the column, this is what you belong to. So the thing is, normally with a layout system, you're stuck. So it's so hard to resolve a layout that it's all done in code, and you're given ready-made solutions, and they give you an interface to use that you could make a custom layout with like code, but still there's a ton of edge cases. And in my case, I ran directly into edge cases that weren't going to be resolvable with like Flexalon, which is the only layout system that you can buy for Unity, and it's good for like scene layouts and animating some cool things, but not for something like a node system where things have to be precise and they have to actually be very functional. So even with a 2D layout, it's pretty complex. But as soon as we added, say we wanted to add, I'll show you real quick what our nodes are going to look like. So say we have a node. So we have a node, right? And actually, yeah. So say it has. So you have input ports for each input, and this is, you could have multiple things going into that input, and then it forms into a list, right? So say this was an adder list, or an add node, just to be simple here. This would be one input, so this would be, say, A. And then the next input, I think I want to make it a stack just for it to look cool, but which isn't that important. But it does make it a little more challenging. So you have these, and then B. And then the outputs would be on this side, right? And you would have, because you have a list of inputs, And then each thing could be a list. So this could be like multiple items, this is multiple items, this is multiple items, and then the same thing here. And then before it goes in, so all of this would get flattened into one list. We have options, but most of the time you want to flatten it into one list. And then all these the same way. And then the output would be a list of numbers of each list. So you have this A, this is B, and then the output would be the sum, right? And it would be line items of the sum. So this is really useful for like they use it Grasshopper for Rhino, and you can do procedural mesh generation. But I like the scheme anyway because this is very conducive to parallel processing. And with nodes, like you could have loop nodes, but it's nice to default to lists of things because almost every operation in code you're going to do a list anyway. So that's the reason why I'm doing a node system. But so look at just this simple layout here. Let me erase some of this. Delete. If we made each node like independently, like so for every type of node we have, we also like redesign the whole 3D graphics and stuff, it would never work. Like you'd never get it done. And so you have to have a node that will adjust to multiple things. And these will protrude. Even if you can't see them, they have to protrude so you can detect when something's being attached. And so say this was a different kind of node, and this was, the label was longer, and it went longer like this, then you have to resize this way. And then this would need to match that. So they call that a fill. It sounds real simple, but it's not that simple. If anyone's tried to build a layout system, it's not that simple. And that's why they don't make the layout systems very customizable. And then, but you wouldn't want it, so when you get the bounds, you don't want to consider these. So if you consider these on the bounds, like the ports, then the width is too wide. Like when you try to match these widths, it's not going to work. They're going to cover up the ports. So you want to be able to ignore the ports sometimes, but then when you go this way, you need to consider the ports. Because what if each time we drag an input to it, it should add a port? And this is the simplest possible node design, right? And then if it's on a transform, so let's go back to here. So if it's on a tree, right, you have this row. Okay, so this is I call it a row, but it's so I did a row, it should be called an alignment, right? So this is aligned with this in order to be in front of it, according to interpolation. So let's see if I can pull up, zoom it, so I can draw on this, zoom it, zoom it. Draw. Control 2. Okay. So to draw and zoom it is Control 2. Right. So an alignment, so it has like, so on the first item you specify 3 numbers, and each number is from 0 to 1. 0 to 1, and if you rotate it in the, this direction, it's also 0 to 1. And that just says like, okay, how do you want them aligned by the left side, the right side, or like centered on each other? And that's in each dimension. All right, so that's a row, right? And then, so I'm just going to call it a line and space layout. So you specify the spacing, and then the same thing with this row right here. So the thing in the front is also, I'm calling it a row, and it has these 3 items, right? So the way that I resolve it in this system is on the top level, like at the root, I have execute depth first. So execute depth first goes through every branch and goes to the, the bottommost thing in the branch. So first it would go here, and then it would go here, and then it would go here, and it would say, are there any lists of operations to execute? This one doesn't have a list of operations, so then it would go here and check, and here and check. None of those have operations. So then it goes back up and it says, all right, that's the first operation that I need, or first list, because see, this has a list on it of layout operations, and I call it C3DLS, the Composable 3D Layout System. So ops, so there's a list of ops, right? And so this is called space and align. That's the name of the game object. This name right here. So that's all it has, but it can have multiple items. So this makes it composable because they execute in that order. So that with a lot of layout systems, you just have to, you get unexpected behavior and you have to guess what the settings mean, because they're called things that, because there's each thing is very specialized. That's not what we want. We want people to be able to put something together, like maybe like resolving a stack in Magic the Gathering or Yu-Gi-Oh versus trying to figure out which Windows setting to look for to change your microphone. Does that make sense? So much easier to just learn the basic rules of something if they're predictable and that they're flexible and they can handle all the edge cases. So yeah, so we go here, execute that list, and then come up here. This also has a list of things to do, and it's another space in a line, right? And then, oh, right. So first it does the row here, and then it goes to the rounded cube, and it resizes it. So this gets fit to the background. Anyways, depth first. Everything's executed depth first, and it looks for an ops list. And anytime we add an operation, so with the rounded cube, for example, we add this C3DLS corner preserving scale, it automatically adds itself to the list. Where's my list operation? Layout ops list. So there it is right there. And then if we disable it, it won't execute. And then for each thing, so for each operation, while the user is building their layout, which the user is me right now, they can execute it. So in this case, it's a resize. So you can test it out as you go. But depth first, and in almost every case, a layout that's a user interface, you start at text, so you determine the text height and you build everything outward from there. And then, which is counterintuitive because in real life you think about the thing first and then you go inwards. But what's problematic, right? And the first way I tried to solve this, remember, if we go, remember this problem, where you need to ignore the ports on one like, sometimes ignore the ports and sometimes not, as far as bounds reporting, because everything goes by bounds reporting when you do an alignment or anything else. And the bounds has borders, the bounds has padding, and you need to choose whether you're going to ignore the borders, ignore the padding, etc. And so, boy, when we do a scale operation, my first idea was to be able to specify a separate target for each operation. So this rounded cube is the 3D background, right? And then when I added ports, what I was going to do, and this would work, right? But not as well as the new solution that I'm going to implement. But I'm thinking it through. That's why I'm filming this. This is not a tutorial. This is helping me think things through. So, think to resize. So for any operation, you specify the target. So instead of the target being on, like having to be on the thing that the component is on, you could specify a different target. So you have flexibility. So you could have a list of operations. You know, you could do all the operations from the root if you wanted to. You don't want to, but for experimenting or trying to figure out how your layout's going to work, that makes it a lot easier too. And then you could afterwards just copy that component over to where like we really need to go for things to be organized. All right, so you would specify separate targets, which is great. And the reason why I did that is so that, like, so a mesh has a whole bunch of points, right? So for like, you see all the lines on this. So you have these lines. Each one is like a bunch of points, a bunch of points, a bunch of points. And this is just a simple object. But then if you go, you know, if you rotate it, then you have a bunch of points. So it winds up being, you know, that's what, it's like 10, 10, 10, 10, 100 points. So if we resized it 3 times, you don't want to resize the mesh 3 times, because it, like, rewriting a mesh is expensive, and games need to be fast, right? So with a game system, they usually use to change the size of things a transform. So transform just has like a 3x4 matrix, and matrix multiplication is really fast, and then they use it when they render or to determine the size of something. But you'd have to do it like, so even then, if you resizing meshes is expensive. So, but the problem is, these should be individual prefabs, and they don't know anything about the column. They don't know anything about their parent. In fact, like, this may be an individual prefab that you drag into row with background. So we can define separate axes, but that might not be available when you add the item. And if you add it in game, then your code has to account for when you add the object, and then you have to account for, oh, what was the thing that I have to resize it to, and if you change the ordering on your on the root node, or like how the node is set up, the things higher up in the hierarchy, then you have to change it on everything. So that can become a tangled mess, and you get circularities. And then another reason why they don't typically do it this way is the order of operations. So it looks simple, but when you do a layout, first you're resizing like the text, and then say this, you know, the bridge or whatever control is going to be there. You know, here we just have a code. This is for testing. But see, this one, it's a different I made the text a different size, right? And I set it up like this to show what the problem was too. So if you look at it, it's scaled to that. Now how do I specify that I want the width to fill the rest of these? I would have to specify that I want it to fit the width to this column, which I could do in the case where I'm experimenting and setting it up not in game or in simulation. So because in simulation I might not know which column that is specifically, especially if the user is going to make new inputs, like say it was a Python node and the user is going to ask, do a voice command and say, make it, here's my inputs, here's my outputs, make a node that will produce a a spreadsheet or something like that. All right, this is hard to explain to someone, like, I don't know my exact audience, but layout systems are really tough. And then, how do I tell it when to exclude those ports, etc.? So that's why I was doing them separate. And then I thought, so we can't do it that way, and we want to be procedural anyway. So what we'd really like to do is first, so here's my row, and here's the content. First, I would like to scale the rounded cube to the width of the row. And I can do that for each one, but that's one full mesh resize. Then what I'd like to do is when I get to the column, I would like it to look at all of these sizes, right? Let's see if I got it drawing. Control 2. So I want it to look at all these widths and resize them all to the largest one. And I'd like to also do it for the panels, so the port panels, these things. Escape for the port panels. So what I could do is say, all right, I want it as deep as the depth. I want to consider only the depth here. So, and ignore the width on this one, and then only the width here. Right? So that was the solution. So with my current solution, where I could specify for the resize, so the resize on the background on the cube, separate X, Y, and Z target. I didn't want to do 3 resizes, so I deferred the resize to when the depth first execution gets to the top. But then when I did that, I wound up with this. So let's do it. So I turned that off for most of them, because here's what happens. So if I go to the top and I say execute recursively, boom, it had aligned it. It deferred all the resizing to the top, right? And I haven't really, I didn't really set everything up exactly because I'm making a new system, so I didn't spend much time doing it. But like, you can see, if I defer the resize to the top, then it moves, right? So that's not what I want. So what I resolved to do, or the new system, will allow me to resize as many times I want in different parts of the tree or in different lists. So I can do it logically. Okay, you know, first make, first set up the text and the different menu items. Now, now set the width to that, or no, you don't even have to set the width to that. You could say now, now make the ports, and now make the stack. Now set the width to the widest one of the contents of the stacks, and then set the depth to the widest of the. You have to be able to compose it. Like there needs to not be like if people have to learn one way to do it, otherwise it doesn't work. It's so frustrating to try to learn a layout system like that. So and we can't defer it to the resize to the end, because then you can't think procedurally. Which this system, you want to be able to just think, use spatial reasoning and think things through. It's a lot easier than learning a one-size-fits-all layout system and then realizing at the end that there's just no solution, or that you have to hack it and you have to write special code. So, so what I decided to do is, for bounds already reports in squares or cubes, right? Rectangular prisms. And then if you wanted to orient a bound, so say you had a cube turn this way, right? You specify the transform that you want those bounds in. So you may want like transform. So that would be x, right? And then this would be y, and then this would be z. You might want it in terms of that transform, so I guess that would be, say that corresponds to this one. Or you might want it in terms of this one, in which case it's like right side up, so this would be y, x, and z. So, of course, I have a function to get oriented bounds. So the oriented bounds for this box would be a bigger box that encapsulates it. So it would be something like, something like this. So that's how you get bounds reporting. So for any resize operation, I have it to where you can have a ref target, so that's the transform. This video probably makes no sense. That's okay. As I go through it and design it, or at least once I have it finished, I can at least show you how it works, but it's hard to explain exactly how complicated these problems can be. But normally they have to do like a measurement pass, a resize pass, a reposition pass, a remeasure pass, and then another reposition pass. And then they hope that the whole thing resolves itself, and that the user's happy. So, where was it going with this? Okay, so what I'm going to do is have a transform for each of the 8 corners. And the way I'm getting bounds anyway, since I want oriented bounds, is I have to get bounds corners. So on each game object, I have 8 corners and their transforms. So in Unity, transform looks like this. So anyhow, that thing. This thing, there's a transform, there's a transform, there's a transform. You could have empty transforms. So when I resize something, rather than reposition it or whatever, rather than doing it actually, and then, rather than doing it actually, I place the 8 corners where they should be. So, and then this, by doing it that way, so I would have boxes around everything, but the things haven't changed size and they haven't changed positions. By doing it that way, like oftentimes in a layout, like you perform an operation and then you have to recalculate bounds after the operation. So you resize something. Now at the top you have to recalculate all the bounds, and it's hard to know when to recalculate the bounds and when not to. But if you recalculate on every operation, then it'll be extremely slow. And in a simulation or something with nodes, you want stuff to be so fast that you can animate the layout resize. So I've said I need to go to Toastmasters again because I'm saying a lot. I need water anyway. Hold on. So we have boxes around everything, or boxes defining things. So this would be a box with 4 corners. So you have 1, 2, 3, or 8 corners, right? And then in addition, it would have a centroid, or a pivot, which is different from the actual transform of the mesh itself. It just says how say the borders were of unequal size, you need a pivot so it knows how to center on its target. So once you define the boxes, basically, after all the layout functions execute, if you hit all the meshes, you'd have boxes showing exactly where the resized meshes, size and position of where they're going to be. And then from there, it's really easy to resolve everything. So what the user saw was a procedural. The user followed procedures. Resize this way. Okay, now that I've resized it this way, I have those bounds. So now I can use it to position this or to resize this. Now it's like, okay, well now I need to know the depth, so let me resize the depth. So you can reason through it, which you normally can't do in a layout system. And so that's what we want. But as far as actually resizing the mesh, if we resized it every time and then recalculated the bounds every time, and we let the user do procedural like that, not knowing when to go all the way, recursive down and recalculate all the points and all the bounds, it's just not going to work. It'll be too slow. So this way, not only is it a clean pass, and we are if the user wants to, it's a clean pass. I'll explain the other part in a second. Not only is it a clean pass, when they calculate bounds, recalculate bounds on something, all they need is the 8 corners. So you just go all the way down the tree, get a list of all the corners, and then get the min and max along each dimension. And at whatever part of the tree, that's the bounding box of that. So it goes all the way down, all the way up, gets the world positions of those corners, and then there's or you could gets the positions of all those corners in terms of that space where you want the bounds at. So that's super fast, and you could do it as many times as you wanted, and it's not going to be slow doing it that way. So that's real nice already. And then on the mesh resize, they could do 6 resize operations if they wanted. Of course, you only get one size on each dimension, but maybe later we have a dress right, or spread backwards or something like that. Then that's an additional resize, right? So this allows them to perform all those resizes without actually touching the mesh, and then the mesh resizes exactly once. All right. This also allows us to keep using our interface. So the programming interface, normally a programming interface for a layout system has a measure function, a move function, you have to implement a bunch of functions just to get a custom component to work. And I tried just size reporting, implementing that on someone else's system, and there were 4 functions for that, just for the size reporting. You had a resize function, there was, it was ridiculous. And so, like, and the manual had discrepancies. So I looked at it, I was like, I don't know which one to do. I'm getting unexpected behavior. And then ChatGPT looked at it and was like, hey, this is frustrating. It's contradictory how they're explaining how you should implement these functions and what they're actually supposed to do. So what I wanted was, if the user wanted to code a new component, or even when I add components, just one function, no arguments, no return value, just executes. Which should be, it sounds silly, like you should have to pass information, but on a component system, that's the idea. You don't pass arguments at all. So Unity is a component-based system. It has two ways of doing components, but so yeah, each of these has components, and the way that it passes information is all the components are mainly doing operations on the transform, and the game object, and standard things like bounds, text render. The arguments doesn't need to be passed. The components modify each other, but then you don't know the order of operations on that either. That's another long story. Anyway, so this scheme allows us to have an interface that has one execute function, because we do like a hybrid between just size reporting and a resize. We actually place the corners in space, and that way we can preview our operation as well before we move on as to where the corners will be at least. That was another thing, is if we deferred resize to the top, then as the user develops their layout from bottom to top, they can't preview what they're doing. They would have to defer the resize all the way to the top. Sounds complicated, but my new system will be called Composable 3D Layout System. Layouts are resolved procedurally. Why hide that? That'd be like the slogan. All right. Well, I hope that wasn't too confusing. But that I was trying to reason through it and then show what problems that I'm trying to solve. And I suppose only someone who's tried to make a layout system would totally understand what I'm talking about. Okay, thank you.